Hello, thank you for joining and for your patience while we sort out this stuff. My name is Robbert Jongeling. I will be presenting our project number 35, which is about managing model inconsistencies or um, inconsistencies in general between different development artifacts. They may be models. We will see later what we mean. I try to forward the slides with this thing. Okay, so the first question based on the title, since we call our project Managing Model Inconsistencies, the question is, are you modeling at your company? And my argument is probably, because as later I will show that we include many things in models, so we don't necessarily include only very formal models like class diagrams, UML diagrams, or system models, or these things, but we can also imagine more informal architecture diagrams or all the diagrams that are used to capture the intended structure of the system or the intended architecture of the system, for example. So we have we start out from this idea that we have a bunch of these kind of core development artifacts, by which I mean that they are created collaboratively and iteratively throughout the development process, and they are also maintained throughout the development. So you kind of aim to keep the system consistent with those artifacts that are created. You want to make sure that those artifacts are accurate documentation of your system on one hand, and on the other hand that your system follows, of course, the design that you lay out in the beginning. So they are not only for communication, but they are really artifacts used throughout the development. All right. And then what we are focusing on is managing inconsistencies between those diagrams, between each other or between those artifacts and the implementation, for example. So you can imagine that if I have now an implementation that follows these diagrams or these models that I've created, I would like to know that I can rely on those models as an accurate representation of the implementation, so that I know that they are correct. Correctly describing my implementation, and the other way around, I want to know that my implementation follows my design. And in particular, what we are considering is settings where you are doing kind of a continuous development using these models. And I use this term for continuous model-based development, but in particular to offset from kind of very strictly gated development phases. So we don't really consider having very strict gates between these kind of development phases like here, but instead we say, okay, we do development in short cycles in each of these phases, and you model just enough in each of these phases for capturing whatever you need at that moment, and then you continue already with the next development phase, and you keep doing this all the time. So the important thing about this continuousness is to offset from strictly gated phases. And an increasing challenge if you have a setup like this is to ensure that you have this consistency between the different artifacts that you create in each of the phases. Yeah, that's kind of the starting point. And then when we discuss about inconsistency or consistency, we can describe what kind of consistency do we really consider. So what I'm describing is we are looking at structural consistency between the artifacts. We are not that much looking at the behavior described in the artifacts, mostly because the behavior, especially when we are looking at these quite high-level models or informal diagrams, there's not that much behavior kind of specified in them that we could even do something with. So we are looking at the kind of at the structural level about static information about the system. And then when we have consider the different artifacts, like here we have on one side models of development artifacts and some implementation, and so we want to know that they are consistent. And by consistent, I mean that they should not be contradicting each other, those artifacts, and they should not be contradicting, let's say, with respect to the expectations of the engineers. And that's why I'm saying that consistency is not in a way absolute. So in different settings, the same artifacts could be considered consistent, but in another setting could be considered not consistent, because it depends kind of what you expect to get out of them. And then when we look at consistency management, or so managing these consistencies or dealing with inconsistencies, it's quite often about kind of preventing that they do any damage. It's not about ruling out any inconsistency. There will always be inconsistency, and you have to kind of live with them rather than trying to resolve all of them. So this is kind of the broader setup of our research topic. And then I have some results that we published this year. And this is we did a kind of quite broad study of the state of practice, let's say, in 13 settings across nine companies that we work with within Software Center, but also outside of them. And by setting, I mean, for example, a development team or something. So that's why we can have multiple in a single company. And then what we wanted to know is what they are doing in terms of consistency management, in particular, kind of what things that they want to have consistent with each other, and what problems do they run into when things are not consistent. And then some detailed things there. And also what work do they have to check for consistency, and how do they keep track of traceability or correspondence between different elements? And also, what do they want to achieve in the future? So we created this kind of schema to try to identify and map the states of practice in these different companies. And then, if I at a very high level try to summarize the findings of this, in the first kind of thing we wanted to know is what type of artifacts do people really want to look at when they want to check consistency between the artifacts. And I distinguish here kind of 4 categories that we encountered. These are, of course, not the only things that you can imagine, but these are the ones that we encountered when we looked at these settings, right? So it was between software design and implementation, software design and testing, architecture and implementation, and settings where you have many artifacts. So you can imagine that you would like maybe to include even requirements and design models and implementation and kind of everything, and want an entire network of artifacts to be consistent with each other. So these are, I distinguish these kind of settings. And when we kind of consider what kind of problems you might run into when things are not consistent, there's a kind of cases where people say that they do not run into any problems with inconsistency. But my argument is that in those cases, the artifacts are not really used as development artifacts. So if you create, of course, your diagram just as an initial sketch, and then you put it in Confluence or wherever you bury it in some slide decks, then it doesn't matter so much that your implementation does not follow that design. But of course, if you use this diagram as a development artifact and you want to maintain it all the time, then it needs to be consistent with your implementation. And then the other problems are kind of in the 2 directions that I sketched before. So either your design contradicts or your implementation contradicts your design, and this might even propagate throughout multiple artifacts. So if you base a first artifact on a model and these 2 are inconsistent, and you then build other parts of your implementation referencing this one inconsistency, then you might propagate further this problem. And the other direction is that you cannot rely on the model as a documentation of the system that you have implemented, because there's inconsistencies between the model and the code, let's say. And then when we look at what are the companies in this study doing currently to manage these consistencies, we found that they actually have quite little support for consistency checking between artifacts. Most are relying on quite implicit links between artifacts, like name equivalents, for example. And there are very few cases where they are doing automated repair of inconsistencies once they are found. And so there's a kind of gap between the ambition level of the companies, or we found that, and what they are doing here, because the ambition level is kind of to go towards, as I mentioned before, this kind of continuous development where you could continuously, or in short development cycles, develop all these different artifacts, and then you want to be able to have more support for consistency management, just because otherwise the manual actions kind of impede you to do these short cycles. Yeah, so this was that I was saying. And then for that we kind of summarized the need for consistency checks in a term that we kind of together called lightweight consistency checking, and that consists of 4 different aspects. The first is that we need to be able to deal with various types of artifacts, so it does not exclusively have to be proper models, as in UML models or SysML models or so on. That is used in many of the, let's say, the scientific approaches. People require proper models because you can parse them and you can play with them, you can transform them into other models and so on. But development artifacts that we encounter kind of in the wild a lot are much less strict. So they are informal diagrams, kind of boxes and lines, drawings, and so on. You have to be able to tolerate inconsistency, because there's always kind of inconsistency all the time between development artifacts and implementation. And it's not about resolving everything, it's about dealing with the things that are not consistent yet. And we need to be able to provide ways to, in a lightweight way, provide adoption and in existing industrial settings, dealing with existing already artifacts and tooling that is in place, and also making sure that if we introduce consistency checks, that they don't themselves become a very complex development artifacts that itself needs kind of maintenance and consistency checking and stuff like that. So these are the kind of needs that we summarized in lightweight consistency checking. And then I'm jumping over kind of the individual contributions that we did in the project, because I'm kind of, what I'm summarizing here is also what I compiled into my PhD thesis, and so I will not talk about each of those things because we cannot make it in 2 more minutes. But instead, I've listed some areas that would be interested in collaborating with you if you have some work in this or some going to thinking about these things. So I'm interested in looking at this kind of continuous model-based development settings and helping you to migrate towards them. For example, by providing this kind of lightweight consistency checking between various different development artifacts. And in particular, now we are quite interested in looking at informal diagrams and stuff like that. So to check if we can deal with informal diagrams and capture the knowledge that is hidden in a way or locked inside these informal diagrams, to capture them in a way that we can use more for automated analysis tasks like consistency checking, but also other things, for example, reuse analysis or change impact analysis or this kind of stuff. I will skip this slide. It's a bit of a summary of the findings of studies in my thesis, where I say the most important things, and a summary of the contributions of my thesis, but you can read the abstract of my thesis, and you know. And the reflections on the contribution. I will also skip this because I want to have a bit of time to also discuss the future of this project and the future work. So in conclusion of this kind of consistency checking story so far, the companies that we have looked at in this study, they are kind of trending towards doing this continuous model-based development. And an important challenge when they do that is managing consistency across these different artifacts. And then for adoption, really in industrial settings, it is worth to focus on these lightweight consistency checking mechanisms, where lightweight is according to those things that we defined. Yes, I need a kind of gradual adoption path towards that. Then, just 1 minute, want to discuss this kind of idea of what we want to do now. So in Sweden, you have this word I learned when I came to Sweden, lagom, which is kind of just the right amount, not too small, not too big, not too cold, not too hot, and so on. And when we consider this kind of spectrum between completely informal diagramming, like drawing boxes and lines on the whiteboard, to very formal and strict modeling, creating UML diagrams or SysML diagrams or other diagrams, the question is kind of where on this spectrum is lagom for specific cases. And so what I'm now considering is to work on more what I call malleable models. So models that you can bend and work with without them breaking. And they should be malleable along two directions, I think. One is between these informal diagrams and more strict models. So you can kind of include both from the model side, you want to be able to include more informal things. And from the informal side, you want to model a bit more things. So you want to capture the knowledge that is inside these informal diagrams in a way that you can use them in automation. And the other dimension, the vertical one, is about the abstraction level. So how much detail is shown in these in these diagrams, because you want to be able to reuse in a way the knowledge that you've already captured in a way that you can communicate to somebody else exactly the information that they need to know without having to create a new diagram, for example, and so on. So that is what I envision in the end, to have kind of fluid movement along this spectra, while you allow to benefit people both from diagramming and modeling and from communicating things at the exactly right level. All right, so this was the kind of summary. Here's our contact information, and thank you. Now we can have some questions or move to the next.
No, let's have some.
Questions?
I think to make up some